Hey everyone, hope you guys are all having a great day. I want to welcome you to today's webcast, Gaining Observability to Monitor Microservice Applications, sponsored by Instana and brought to you by adtmag.com. I'm your host, Abu Mukabam, and before we begin, guys, just a few housekeeping reminders to start. We are recording today's show for future viewing purposes, and within 24 hours, we'll send you a link to the email you registered with where you can find the replay. So keep an eye out for that. And feel free to share that with others who may be interested. We'll also be having a Q&A session at the end of today's program. We do encourage you, however, to enter your questions at any point using the Ask a Question box on the lower left of your console. Now, we'll get to as many questions as time permits, but please don't be shy. Ask away. Also, don't forget to check your resource tab in your docs for any materials associated with this show. So we do have a couple of links and some resources for you guys to take a look at. So that being said, I'd like to introduce today's speakers. We have a couple of good ones. So we have Chris Farrell. Chris is a marketing director at Instana. He has been working in high tech for over 25 years, with almost 20 years in application and IT monitoring. And joining Chris today, we have Hugh Bryan. Hugh is a APM expert, and he has been working in the enterprise application performance space for the past 15 years. So guys, you're in for a treat. And thank you guys for joining us today. Chris, the floor is all yours.
Thanks, Aboom. Appreciate it. It's really scary to hear the words 25 years next to your career title, but it's nice to be here. Thank you, everyone, for joining us today. I know you're here to see Hugh show you some cool stuff and not hear me talk about stuff, but I am a marketing guy, so that's just tough. But we'll get to Hugh quickly. One of my favorite analysts in our space, the application management space, or even IT operations, was Jean-Pierre Garbani, or JP. And he's retired now, but he was at Forrester for a long time. And he wrote a blog post that I guess it's going on around 5 years now, where he wrote in the blog post, you can't manage what you don't see. Now, there are other operational geniuses in the past, other than JP, that have said similar things, and people have argued whether or not that's a part of a well-performing system or not, is the ability to see inside. But I thought I'd take a look and see if there were some people other than JP that had some information about observability. Now, I started with being a marketing guy. I thought I'd go get some cool pictures. So I went to my account at iStock Photo, where I get royalty-free pictures, and I put in observability. And unfortunately, there is not a single photographer or artist in the world that has loaded a picture into iStock Photo that has observability tagged as the keywords for it. So unfortunately, we fell down a little there. But I was undaunted. I was going to find someone else telling me what observability is. And of course, where can we turn to but everyone's favorite, Wikipedia? And Wikipedia Google and Wikipedia. So when you search for Google for observability, you get this Wikipedia article as the primary definition. In control theory, observability is a measure of how well internal states of a system can be inferred from knowledge of its external outputs. Wow. That's a really convoluted definition to say observability is the actual ability to see inside your applications. I'm going to move it away from systems and on to applications. And if you think about the history of the application management space, that fits really well with the first and second generation of tools that came to our space. So if you think all the way back to a long time ago when we first introduced Wiley to the world. I say we because Hugh and I both, that was our first place where we experienced each other and the application management team, or the application management world. And the whole point of those first few tools was essentially creating observability inside first Java applications and then finally some .NET applications. So that whole world revolved around the fact that all the transactions would go through the Java code, and you had to see what was going on in those platforms in order to understand how the actual applications, and more importantly, how the users of those applications were being served or were serving those users. Now, as we got into generation 2 of this world, this beautiful world of application management, the technology shifted away from one single big giant application into a distributed environment, still built around these languages, though, of .NET, Java, add a few more, maybe some Ruby, some other application languages that came along that started to become useful in web applications. And in that world, it was about being able to understand what that application looked like from a flow perspective, and then do some deep profiling on all the different pieces that existed in that application. But it was still a homogeneous environment. It was still dealing with things that were configured up front and might have some loose connections, but pretty much were baked and put out to run in the world of production web applications. But microservices creates kind of a different way of thinking of the world. And in fact, I'm going to show you a stylized map of a small microservice application. I say small because this is actually a screenshot of the architecture that one of our customers has, but it's actually one of our smaller applications that exist. And what you can see here is that you're starting to talk about, when you start to talk about microservices, hundreds of services, thousands or hundreds of thousands of interdependencies. And by the way, all of those things are subject to change. There's the aspect of microservices just in their definition, but there's also this concept of dynamic applications and things coming up and going down and containers being there or not being there, and using these new technology, these beautiful new technology platforms to create this world of extreme flexibility, but unfortunately that comes with some visibility issues. So what I like to think about when we think about this is to talk about all the changes that happen at the layers. We have new kinds of on-demand hosts. We have not one or two middleware vendors, but dozens of middleware vendors. And they're not all just tied around a piece of code, like a piece of Java code or a piece of .NET code, but they're literally doing functions in the middleware itself. You have clusters of things, whether it's orchestration of something like Kubernetes or just a clustering functionality in a microservices technology. And then the last piece, the fact that things come in and out and provision. Because one of the things that we're trying to do, of course, is be much more efficient in how we're actually managing these applications, or more specifically, how we're deploying these applications to meet the demand of our users. So with that, let me give you a little context of where we came from and how we started. We were founded by a bunch of guys that were APM experts. They had been at one or maybe two different APM tools in the past, vendors in the past, and even when they weren't, they worked together with those APM vendors. So our founding team has a lot of strength in this space. And actually, the way that it gets described to me by one of our founders, our Chief Operating Officer, Pete Abrams, is that all four of them kind of came to the same conclusion around the same time, which was there's this whole new world of technology coming down the application path, and the management tools are not in any kind of state to deal with it. And it's not that they can't deal with the technology itself, it's that they can't deal with what it's going to do to the organization. They can't deal with what it's going to do to the way that it operates. So it's not the technology, but rather how technology is used now. And that's what founded Instana. And what's really nice about it is customers agreed with that. So unlike all of the other tools in the past, immediately two things happened that I had never seen before. And I'd love to get your perspective. You've seen this before. Right out of the gate, we had enterprise vendors buying our solution to do stuff with. By the way, not to replace necessarily those other tools they had, but to deal with their new microservice applications. And the other thing that I saw that was different was that APM was now important to all kinds of technology companies, even small startups. They knew from the start, our application is our lifeblood. It must perform well. So these were two changes and shifts in the marketplace that were tied directly to the way that these applications are being deployed. Hugh, any difference that you might see?
No, not at the moment. The big thing is change. going to be dynamic change, applications with lots of moving parts, and how do we gain observability?
Good points. And I'm going to add one more word to that set of pieces there, context. So
yes,
context is critical in microservice applications. You can look at a single service, and that's nice to look at availability, performance, throughput, but without the context of how that service is being part of larger applications that are serving up different needs and transaction requests to the end users, whether those are people or other systems. I always like to think of the anecdote of the blindfolded scientists being told to figure out what an elephant is. And depending on where they were, they had a different answer. The person at the tail thinks it's a rope. The person on the trunk thinks it's a snake. The person on top thinks it's a fan touching the ears. But without the context that all these things work together, you don't really understand what the big thing is. It's an elephant because it has all these things, but in a very specific pattern or use case. So what does that mean for microservice applications? Well, in microservice applications, you have a polyglot of languages on any given app. And this is happening. And here's what funny thing about operations teams and this. I met a lot of operations teams over the years that they want so much control over their systems. We will use this middleware. We will use this messaging. We will use this language. Well, in a microservices space where you give more both responsibility and control to the developers themselves, they're going to pick the best technologies for what they need to do. So whether the ops teams are ready for them or not, you're going to get 3, 4, 6, 8 different languages as part of any given application. Now, not necessarily every application is going to have this polyglot of languages, but a lot of them do, and it can be a real problem depending on what your tools can deal with. Another interesting aspect of microservices, I talked about this explosion of middleware. And one of the things that does, it means that business logic is occurring outside of the actual code. You're literally doing transactions where there is no Java code or .NET code controlling or even understanding or even making the request to do this business logic. So how can you see the performance of these new components? And then the last piece, we talked about the dynamism, the fact that transactions can take paths that A, differ all the time, and B, aren't connected to code. So how are you going to deal with these different dependencies, and how can you see and track all this dynamism? And that's what we're referring to as APM 3.0. Now, there are other tools that are that have made slight movement towards this space, but we're just going to talk about the things that we know from talking to that set of customers and what those DevOps teams are looking for. The APM 3.0 is made to deal with the ideas around quick, agile, more frequency of rollouts, actually getting to the point where your developers are more like service owners and they can update and deploy their services whenever they need. And in that world, immediacy is the most important thing. When something gets deployed, can you immediately see it? And is it giving you actionable information, not just a little piece of performance data? And to deal with all that change, it has to be automated. So we have another recording. After you finish listening to this, I would recommend that you come to our site. Certainly, you can try it for yourself. Once you see Hugh showing it, I know you're going to want to see it. But we also have a webinar that we did with Edmunds.com recently. And one of my favorite stories that came out of that was that as they made the shift to multiple deployments per day, they're not just their problems, but the actual alerts that the ops team got fell to almost zero. Now, it's obviously not zero. You're going to have warnings and alerts, but the quality of the code became so great, and the way that the code interacts with each other became so refined that their actual alerts per day fell to almost nothing. So it's a great customer story and a good exercise in automation. And why do I talk about automation so much? Because in this world, a lot of broader more complex, loosely connected, many different technology and languages, one of the things that people have turned to is writing their own monitoring code, sometimes with proprietary things, sometimes with open source. But the idea of writing your own monitoring code to deal with all those problems that the first and second gen tools couldn't handle. I don't fault anyone at all for doing this. In fact, we support all of the open source tools that are out there. But one of the things that you have to understand is that when you manually set a monitoring strategy in place, all of these things on this page have to be manually done. And that means you've got developers spending time on things that aren't writing their own code. I know everyone wants to get to see something in action. So let me show you how this actually works, and then I'm going to give it over to Hugh. So we actually work by having just a single agent. It goes one per host. That agent discovers everything running on that virtual or physical host. It will then deploy all the monitoring sensors that are necessary, whether it's at the Docker level or Kubernetes or Java sensor for going deep into the Java code, or a middleware sensor to deal with something like Kafka or RabbitMQ. And then we'll start tracing all the user requests that come through the system. And we will do that for all the user requests. And it's really important to understand the philosophy is to get every request across every piece of technology. So that drives really well with the microservices world and with multi-frequency of updates world. With that, I'm going to turn it over to Hugh. One last statement before I get there. How do we do this? The big part of it is modeling, but not just a straight model like we've seen in the past. We have something called the dynamic graph. It has dependencies in it. It has performance metrics in it. It keeps concepts of configuration in there. It's got some preloaded concepts of what makes a specific platform healthy or not, and that's all tied together using graph theory. And that is what allows us to have this contextual information to kind of take the next level of application management. So with that, I will pass it over to Hugh to do a demo.
All right. Let me know when you can see my screen. Let's see. Let me double check here. 1 second. Here we go. Entire screen. Okay, here we go. All right. Hi, you should be able to see my screen now.
We see it, Hugh. Go ahead.
Great. All right, thanks so much, Chris. So Chris hit on a very key point that I like to emphasize as I drill into the demo, and that's the idea of the graphs. And from a perspective of modern application architecture, what we essentially do is we re-image or create an image of your enterprise environment in our software. So the sensors that he described, which I'll show you here in just a second, will literally create something that we call entities. And entities will have properties and will be linked to other entities, and we'll create an image of your environment in our software. And so what we like to do is start with a quick overview. And that is the idea that what does our solution do? Well, first of all, it's completely automated. We have the highest level of automation in the industry. Now, that doesn't buy you. It buys you some things, but it's not the end. What is it that really makes us special? It's the idea of marrying automation against this new microservice-based environment that changes all the time. Those are the dependencies there. And then we couple that with, or we enable that with our graph. So think about it. What we do is in our software, we have an agent we deploy, and it could go into a Kubernetes cluster. And here you can see a 4-node Kubernetes cluster, and we're looking at all of the infrastructure of that. We have 4 nodes, and you can see the containers here rendered. We can also run in standard environments, running just, let's say, WebLogic on a server somewhere. We also run completely on-prem just to get those things in. So the first thing we're going to do is map out all of the infrastructure. And an easier way to view this is by Docker container. So we can view it by host or Docker container. But what's really nice when I do it this way is I can look at specific containers and the type of technology they're running. So here's a Node.js application. Here's a Python app. And here's a JVM-based applications. We have PHP in here and everything. So when I drill into this, let's say node application, when I open it up, here's what's unique. We have a sensor at every level. So what will happen is the agent will go through and apply the sensor automatically. The first thing it's going to do is say, hey, I recognize that we have a Node.js application, which is also a process that's running in a container that's running on a node or a host. So that's kind of nice. And we're going to do that automatically. You can see there are several technologies automatically discovered here along with their containers. But what I want to emphasize is that there is a sensor at every level. So we have our Node.js sensor, and what does it do? Well, the first thing it does is it discovers the component. It then will give it a name. It'll type it. It'll discover its information, its configuration information, its performance data. It will monitor its health, and then it will say who it's connected to. But we're not done there because we can also do 1-second data in real time. And we're going to do this 24/7. We're going to do 1-second data, hold that data for 24 seconds, or for 24 hours, sorry. And what's critical about that is when you're going to map this to your application and map this to your debugging efforts, when you're looking for root cause, it becomes a critical part of the story. The other thing that we're going to pay attention to is the stack here. So here's our Node.js app, which is a process. And again, we have another sensor here. It is here we can see the type, the name, the metadata for it, the 1-second performance data, and then who are we connected to. But the whole time we're monitoring its health. And of course, then we can see the Docker container and then running on a particular host. As you can see, we have sensors actively running across the board in all cases. Now, as I come back, as I zoom out again at our environment and take a look at it, you can see there's monitoring going on all the time. So if I zoom in on this particular component, we can see what the monitoring of this is. And when I open the dashboard, we'll be able to see that at this Redis node has a particular problem. So our Redis hit rate is below 80%. We have over 200 monitors that get automatically applied through our over 100 sensors. So again, the fact that we can automatically deploy the agent, it goes through and discovers all your infrastructure and does what? Builds the relationship, builds an image, and starts monitoring it in real time. Okay. Now, the other nice thing is to show the benefit of the graph is let's just show me. Let's go back to our Docker container mode, and let's just do a quick filter on some basic components. So I want to see the cart, discount, and rating service individually. And so I can click on each one of those. You'll see that it's just a basic filter language here. I also, though, like to show this part is where we go entity type, and we show you all of the technology we're going to auto-discover, right? Like I said, we have over 100 sensors being deployed out there, and it's doubled since I've joined the company, which is very exciting. Also, this idea of adding a new entity to the graph is not that hard. We don't have to remodel anything. We just add a new entity and start monitoring it and insert it into its place in the graph. Now, but wait, that's not all. So after we do infrastructure, let's look at the services running on top of them. So the next layer we're going to look at is on the infrastructure, we've got a layer of software. And again, this is the software that is written in all those different languages: Java, Node, Golang, Python, .NET, .NET Core, PHP, Ruby. These are all the languages that we support. And as Chris said, to double down on that is we also give you the ability to expand our instrumentation above and beyond the automatic instrumentation that we do. But what I want you to envision here is to envision this layer of software running on top of this infrastructure here. And so that's the second thing that we're doing is we're laying over this software on top of this infrastructure. And the two are married in the software, again, where? Through the graph. and that becomes a compelling story. Now, let's look at our services. Services are the logical entities that make up our software. And services are our first-class citizens, or one of the first-class, let's say, call them software citizens, that are entered into the graph and then monitored. So here we have a number of different services. Our model also includes the idea of applications. So applications are the higher level order item, and they can be made up of one or many services. What makes Instana very, very unique is that we have a many-to-many relationship between applications and services. So I can have an application dashboard and all of its dependent services grouped accordingly. What's also unique, though, and again, I'll reiterate this later on, is that we can also even take a slice of a service and a slice of another service and put those into an application. So we can bifurcate services one or n number of times, essentially, and pull out their calls and roll them up into an application. Now, what's nice about services is that services are unique entities. And the way I like to talk about services, these software entities, is they are entities that call other things or get called by other things. And so, for example, if we look at our catalog service here, what we're going to do is, and this is really nice, this next point of automation, we went through and discovered, the Spring Boot instance under the hood, which we can always link back to in our infrastructure. But we're also going to create a service. We're going to type it and tag it, what kind of service it is. And we're going to build you a dashboard, right? Again, we're going to these next generation dynamic environments that are constantly changing. And so what we want to do is enable you with the critical information you need to monitor and maintain these environments. So we have a number of calls. So there's 20,000 calls with a key performance indicator here of an error rate of 0.77 and a mean latency of 45 milliseconds. But we also want to highlight the fact that we're capturing those percentiles, right? Because we capture every call, it's very easy for us to render percentiles in our solution. In addition, we have this idea of application and then services. What's really nice is endpoints are also included as first-class citizens in Instana. So an endpoint, which is a slice of a service, right? It can be, also gets first-class status. It gets its own dashboard and its own monitoring and its own analysis. And one of the other things I always like to highlight in our software is this idea of when we monitor something, we have all of we talked about monitoring hosts and JVMs. So you can see here are all the automatic monitors for a host, but we also have them for services and applications. So all of our services have their own monitors, all of our endpoints, and all of our applications. So we're automatically going to apply these rules, these monitors, to all of your services, applications, and endpoints. And that becomes a very nice proposition for us. Now, as we move forward, the next thing we want to look at is tracing. So we look at the individual service and who it talks to. We can see it can have a simple or a complex list of dependencies, which is really nice. So here we can see where our catalog service sits in relation to other services. We also can look at it with respect to calls, respect to latency, and heat map data versus errors. And so because we're capturing all of that data here in our environment. So we can even look at our cart service here. We can drill into the cart service and take a look at that. But what we really want to do now is get into analyzing traces. And this becomes exciting because we're literally capturing a trace on every service call. But what I really want to do is get into the weeds on that, because we're going to go, it gets even more specific than that. When we drill into one of our traces, you'll see it's made up of multiple subcalls. we certainly have a trace ID here. And again, this is where we will exceed the other vendors that are out there. We consciously make each individual service call a unique entity, and we characterize it and make it its own unique thing. So not only do we capture the trace, and we do this very quickly and we make this very high performance, but we're able to break down each individual service call inside of the trace. And then here's what's really critical. We then bind it to its underlying infrastructure. So every span, every call, what we call a service call, is bound to its underlying infrastructure stack, right? So we can always link back to the host, the pod, the container, the process, and the application instance, right? So if you wanted to, I could just open this up, pop it open, and say, here's my link right back to my node process. That's kind of cool. We could go even a little deeper. We go all the way out to the node and look at that. We can see what node it was running on. And we can do this all day long. And what's key about this, and this goes back again to those key differentiators, is that we are pinning every service call to its underlying infrastructure stack. There you go, right? So every service call will get pinned onto its infrastructure stack. And again, that's another unique attribute of our solution. All right, so we've done just a quick overview again. We've gone through the solution so far, taken a look at Instana, where we're going to describe your entire infrastructure environment, again, doing this in an automated fashion. We're then going to discover all of the services in your environment. On each one of those services, we're going to build out a dashboard. We're going to tag it and type it. From there, we can map those in an automated fashion into applications, and we're going to capture traces on every call. Now, two more things that I want to discuss, and that is we also fully support EUM monitoring, so we're going to fully capture every page load from your browser-based applications. Mobile is on the way, and we'll essentially use the same infrastructure here. But you'll notice we're going to be able to capture the end user monitoring with respect to page load, transitions, key onload times. In addition, we're also able to look at those key navigation timings that we always care about, because it allows us to look at what the browser performance was looking like, what were some network performance looking like, and what was my back-end application looking like. Additionally, we're going to break down, again, with every page, it's going to have resources that are loaded, and we are going to provide visibility into those. Ultimately, any back-end HTTP requests, JavaScript errors, geography breakdowns, of course, individual pages. And of course, just like everything we've done so far, is we capture we're going to capture what we call a snapshot on every call. And this becomes powerful. We'll capture the beacon. We'll know each individual browser load. And then we're going to also link it to any back-end traces. So we can take a browser call and where the browser information was coming from and link it to your back end. So it's another unique property that we have baked into our solution. And again, it's all one solution. And then finally, how we do error detection and gaining visibility into our environment, and that is through events, incidents, and changes. So we talked a lot about state change, and this is where our state change is essentially tracked or monitored. Any changes on any of those sensors, right? The node, the process, the host, the Elasticsearch, any of those entities are highlighted here. So something goes on or offline. We change the configuration of something. All of those items are tracked under changes. You can see a number of them here, things coming on and offline. We also will have, there's a change detection right there on a specific component, and we can see what it was. So we had a change in a cron job. Oh, that's kind of nice. The next level above that are issues. Any of those events that we were monitoring on our technologies, whether it was services or infrastructure, will be tracked using issues. And these are kind of the baseline monitors we do for all of the components and services and endpoints in our solution. And then finally, we take those and we create something called an incident, which for all intents and purposes can be essentially a container. An incident is a container for related items, right? And then again, this is where the graph comes in, becomes particularly useful, where we have dependency in the graph. We can follow that and see how things are related so we can debug them. So when we have a particular incident, and incidents are fired, and then we have something called service impact and triggering event. When a triggering event occurs, this is what generated the incident. We had these other issues, but now they've been collectively associated and put together to impact one of our end user services. And when this occurs, we generate an incident and build out this incident implementation with all of the related entities provided. You'll also notice that it gives us the time range, what the percentage of errors were, and then a link, again, directly into the calls on the back end. So we can get visibility into, we had a total of 17, we have 26 calls that were all contained errors, and allows us to drill into those and get to the bottom of any particular problem. And we can see we've got, it looks like some kind of problem talking to our database here. Last and final thing is overall analysis. So when you come in to look at Instana, one of the things you can do is say, hey, let's just look at every call. Every service call, every trace can be easily done here. So in the last hour, we had 38,000 traces, which add up to 159,000 individual calls. So we've already got analysis we can also run analysis on the environment by whatever you want. So one of the nice things to do is look at databases, and these can be NoSQL or JDBC databases. And what I can do is come in here and look at it and do filters accordingly. So I can look at all of my MySQL calls, and then what's kind of fun is I can group them by a database statement. And what I have here is the performance breakdown in the last hour of all of my database calls and the individual calls themselves. I can also do this by individual technologies. I can look at a technology, whether it's JVM, and look at individual JVM platform calls, or we can look at we can look at Golang calls or any kind of technology that you want. The nice thing to remember is that while we capture a trace on every call, and this kind of conforms with the open tracing ideals that are out there, again, what makes us different is that we give you more. We not only give you tracing, we give you full-on distributed tracing that's automated, that pins your individual spans to their underlying infrastructure, and we provide high volume and the ability to do it very fast. So, in summary, Instana is the solution for the next-gen applications that are out and alive today. We work very well within the context of distributed environments that are made up of containers and OpenShift and Kubernetes. We have full monitoring for Kubernetes where we break down, not only individual nodes, namespaces, pods, and we have dashboards that are automatically generated for all of those. We're going to break down all of your software into individual services, can roll those up into applications, capture traces on every call, and give you visibility into your enterprise. There we go. I think that's good. That was a good ending, I think. Now let's take time for questions.
Thank you so much, Hugh. All right, so as Hugh exits out of the demo, We appreciate that. We'll go to our couple of questions that we do have here. So, and again, feel free to ask any questions we have time for. We'll ask it. If not, we'll still get back to you. So every question is good. And the first question we have for you guys here is, would this approach work on traditional architectures?
Yeah. Go ahead, you. Before you answer, I'll just say I'm gonna ask it. I'm gonna add a little color context to that.
Sure.
Can we work in traditional application environments like SOA or monolithic applications?
Yeah, absolutely. The discovery works in container as well as just a JVM, a WebLogic server, multiple WebLogic servers or Tomcat servers running on a Linux host in EC2. So we work equally well in those environments. We will also trace them out. We can also give you visibility across the board in those environments.
All right. So the next question we have submitted here is, what about IAAC support for CI/CD process?
Let's see here. Read that one part again. It says IA. I missed the first part.
Yeah, sorry about that. Anton asked, what about IAAC support?
Infrastructure as I'm trying to remember what IAA, something as infrastructure as a component, I think. Maybe Chris, you could look that up. We'll come back to that one.
I'm looking it up. I'm looking it up myself.
All right, we'll come back to that one. Not a problem.
Yeah, no problem. And Anton, if
I
you
think
want to
that
let
is
us know
infrastructure as code, Lou. Hugh. Infrastructure as a code. That's an interesting question.
I think that I assume that's probably talking about lambdas. I suspect. I'm not familiar with that particular term. There's lots of different terms we can. But let me come back to that one again. Let's go to the next one.
Yeah, no problem. All right, no problem. Next question we have is, can Instana work with open source monitoring tools?
Sure. So one of the things we enhance is, and actually for some of our sensors, for let's say Golang and Python and Node, they're actually open tracing enabled. So you can do a couple of things. Number one, our agent will actually act as a Jaeger or Zipkin trace receiver. So if you've already got code that's already instrumented with Jaeger or Zipkin, you can just point those collectors and send them to our agent, and we'll be happy to process those. We've got a blog about that on our website. We can maybe send that out in a follow-up. But it's real easy. Just search on Zipkin and Instana and tracing, and you'll get the hit on that. It's pretty good. We also support open tracing technologies, of course, across the board, whether it's Linux or any of the other things, Java or things that are built with Java, like Tomcat, etc., JBoss. We both work with and enhance those. All right.
Okay. So actually, if you can come back, Aboom, to the IAC question, I think I can give an answer to that. So, can you read the question again?
Yeah, 1 second. All right. So you asked, what about IAAC support for CI/CD process?
A really interesting question. So, as we've talked about how immediate feedback helps this environment. And one of the nice things that is built into Instana is a health capability that you can compare, that allows you to do things like compare configurations between two different things. So if you're using IAC to deploy an environment that's supposed to have X amount of whatever resource, or have one of your middleware servers configured in a certain way, or to deal with certain transactions, one of the nice things is that we will be able to, you could use us to ascertain whether or not the environment deployed matches the environment you expected to deploy, which is a great kind of next level up from or down, however you want to think about it, whether you're talking about going up or down, from what we were talking about with Edmunds, which the idea is when their services team deploys an update to a service, one of the nice things of having real-time feedback or near real-time feedback is the fact that that service engineer can immediately get an understanding of whether their deployment is doing what it's supposed to do and whether or not it's creating performance problems. So move that either up the stack or down the stack, however you like to think about your application code versus the infrastructure it runs on, and have that same capability of instantly knowing that what you deployed is exactly what you expected to deploy. Stay tuned. I'll say stay tuned to us, not today, but over time, and look for some more CI/CD integration features where I think IAC will become more prevalent throughout the language of the product, not just in a conversation.
All right, so this next question we have asks, can the tool work in a multi-tenant environment?
Absolutely. So you can have, so our solution supports the idea of multi-tenancy in two ways. One is you can set up multi-tenants within our software and have completely kind of portioned implementations. And also you can deploy the agent across any cloud or any implementation and aggregate the data however you like. That's what I think, that's the answer for that one. So yes.
Okay. The next question asks, can we monitor OpenStack infrastructure?
I believe that's I believe the answer is yes. I'll have to double check on that.
I'm 99% sure the answer is yes on that.
Yeah. Okay. Good.
Okay.
All right.
And the next question we have is, what do you need to host this application?
So we do SaaS and we do on-prem. From the agent perspective, you deploy an agent on every host or a node in your container-based environment. And then we can hook you up with the documentation for our on-prem implementation. It is a scalable, sizable implementation where we've done some pretty large implementations, anywhere from 1,000 up to tens of thousands of hosts under management and or containers. It's essentially, we actually use a microservice-based implementation on our backend data collection. We just call it our Instana backend impl. And we can get into it's in the docs at docs.instana.com. You can set up a meeting. We can run you through all the specs.
Yeah, but to be clear to everyone, there is a SaaS version and there's an on-prem version.
Correct. And by the way, I noticed the person who asked this question was from the government. So we recently just did a complete air gap implementation for the U.S. Navy here in D.C. That is up and running as we speak. Yes.
That's very interesting. And Hugh and Chris, another question is, can this be linked to Power Business Intelligence, for example, to mix different types of data?
I looked at Power Business Intelligence. I assume that's the Microsoft product you're referring to. I think the way we would do that would be we have REST APIs for all of our data. So we have REST APIs to capture events, metrics, and traces. And you could use that to pull the data into Power Business Intelligence, I assume. I'm not that familiar with Power BI yet, but I can look into it. But I suspect that we have REST APIs that we would use to do integration there.
Okay, and then the next question we have here is, unless Chris, you want to chime in?
No, I'm happy with Hugh's answer.
Yeah, website monitoring. Yeah, so on the website monitoring question, that's a great question. We use, very much like other vendors out there, we have a JavaScript agent we deploy into the environment that captures all of the beacon data and transmits it back to our receivers, our data receivers. The nice thing about our solution is that we use the exact same technology for capturing those RUM traces or those beacons as we do our trace data, and that gives us a lot of efficiency. So it's all done through browser-based beacon information. And I can, again, if you set up a meeting, I'll walk you through all of this. It's very simple. All right. One more.
And looks like our final question we have is, can we set threshold for metrics manually, or is it totally automatic?
Yes. So what you would do in Instana, which is really nice, is you get to do two things. You can describe a new kind of event based on a manual metric threshold. You then can take that metric and then apply it using the graph, both either horizontally or vertically. And what I mean by that is you could apply it, let's say, looking at all of the JVMs in a particular cluster or all the JVMs in an entire enterprise. And that's really nice. You can then take and apply any of those events and bind them to only components either by name or by type. And then on top of that, you can choose then to forward the information, again, using the graph at your disposal. So the graph is not just about rendering and creating the model. We also are able to exploit it as a way to more effectively, in a sense, slice and dice our environment, portion it up, but also monitor it and then effectively respond to the alerts generated by Instana, which is very powerful. And a new feature that's coming down the road is teams. So we'll be able to bind teams to filters where you can have a filter. So teams could only see certain kinds of things. Maybe you only want your team seeing JVMs or certain hosts or certain groups of hosts. We'll be able to have that implementation very easily in our product.
All right, guys. Hugh, Chris, do you guys have any final thoughts or any closing comments?
I just really
none other than
yeah.
Go ahead, Hugh.
I was just going to say thanks so much for attending. It's always a privilege for us to talk to folks out in the field that have real-world problems, and we hope that we can, provide some insight. Again, hit us up on LinkedIn, hit us up at Instana, check out our free trial, and we got some really good articles out there in our blog space.
Yeah, and adding on that, of course, thanks to everyone for joining us, but also if you would like to take advantage of the presentation today, one of the things that we've created is a special link for everyone here. You can go to instana.com/DevOps-trial and just get it for yourself. By the way, our trials are complete full product, including unlimited number of users during the trial period. It's a 2-week trial period. It's not a lengthy trial, but it is long enough to get a good understanding and really get into the heart of what your applications are doing. And I love the fact that we actually don't limit any functionality or any user counts while you're trying the product out.
Yeah.
All right. Well, thank you so much, Chris and Hugh, for presenting here today. We appreciate your time. And I'd like to thank the audience again for joining us today. Yeah. The webcast was sponsored by Instana and presented by ADTMag.com. Thanks again, everyone, and enjoy the rest of your day.